To explore the unknown in outer space, we require some of the most advanced technology as well as experts to build an instrument that's quite effective and efficient in its job. The James Webb Telescope is one of the most complex instruments out there that's not only complex but quite expensive too. The talent of engineers who came up with this instrument was truly tested while coming up with the James Webb Telescope. Hello guys and welcome back to our channel. In today's video, we shall be taking a quick look at the insane engineering behind the James Webb Telescope. Randy Kimball was the project scientist for the James Webb Space Telescope, and he was responsible for the integration, testing, and commissioning of the instrument. The telescope was way over budget, and its production was being delayed quite drastically. There were a lot of issues that came up when creating this complex telescope, but it finally came into being. Kimball had worked on quite a few projects and even worked on creating the famous Hubble Space Telescope. But after that, from the year 2009, his prime focus was on building the James Webb Space Telescope. Kimball had quite an experience creating the James Webb Space Telescope, and one of the highlights of his career was when he carried out tests inside the 40-foot diameter Chamber A, which was basically a testing ground for the equipment that was used by the Apollo missions. The cryo-vacuum test by the James Webb Space Telescope had to undergo were quite tiresome and tested everyone's patience. It took a long time to get appropriate results, as it took weeks to cool and stabilize the system before data from it could be derived. The scientists of this project got no break and had to work on the weekends as well as the other holidays. But eventually, the James Webb Space Telescope came into being and is said to have a price tag of $10 billion attached to it. Many people call the James Webb Space Telescope the first light machine, since it was built to see galaxies and stars that existed sometime after the Big Bang took place. The light emitted by these heavenly bodies is so old that they have shifted into the near-infrared and infrared parts of the electromagnetic spectrum. This shift is known as the redshift. In simpler terms, the shift is observed due to the expansion of the universe and the Doppler effect that comes with it. The stars and galaxies that are studied by the telescope are pretty far away, and the incoming signals that we can get from them are quite weak and faint. Thus, magnifying these signals was what the scientists were primarily focused on. One of the components of the James Webb Space Telescope is the SPF 1,000,000, which also happens to be the largest piece of the aircraft. It comes with a 5-layered sunshield that's made up of an aluminum-coated material called Kapton. The plan was to unfurl the sunshield before deploying the telescope, and this was a part of the post-launch deployment sequence. The sunshield is one of the most important parts of the entire ensemble, and if it does not fully deploy, the telescope would lose its true functionality. The sunshield also happens to be the telescope's main cooling system, and you can find mirrors and 4 instruments behind it that are said to be at a temperature of below freezing at 390 degrees Fahrenheit. The setup also comes with a sun-facing side that's said to reach temperatures up to 230 degrees Fahrenheit. The sunshield attenuates the solar energy, just like how sunscreen does with SPF, and this helps the system to cool down the wavelengths without limiting the observations by the glow that's emitted from the telescope. The sunshield came about after some smart engineering was instilled in it. The 5 layers of the Kapton material that the telescope comes with are radiated away from the spacecraft through spaces. Kapton is both ultralight and super thin while also being sturdy. This helps them to survive attacks by the meteorites when in space. The James Webb Telescope is often compared to the Hubble telescope, especially in terms of the mirrors and results that they both generate. Speaking of mirrors, the James Webb Telescope comes with a giant mirror that helps collect 6 to 7 times more photons than what was collected by the Hubble telescope. The square size of its mirror is quite large, and so is the amount of light collected. The mirror comes with a height of 21 feet, and this huge size enables the telescope to capture sharper and deeper images from outer space. Furthermore, it can do so in a fraction of the time the Hubble telescope took to do the same. The entire setup is the size of a tennis court, and thus shifting this 21-foot mirror into space was no joke. The Hubble telescope was taken into space in the Space Shuttle Discovery, but the James Webb Telescope could not be sent in the same way. The widest rocket that was available at the time was Europe's Ariane 5 rocket, but it could not be used as the mirror was 3 feet wider than the rocket. So to get the ensemble to space, there was a lot of rebuilding and folding that took place. The mirror of the telescope comes with 18 hexagonal segments, each of 4.3 feet. When these segments unfold, they can be locked in together with the other parts, ensuring that the seams between the individual segments are smoothened out. Aligning the mirror is another important task that was done, and doing so can take up to multiple weeks or months, and this is done with the aid of the NIRCam on the spacecraft. So from this, it was planned initially 18 separate images will be captured with the NIRCam, and all of them will be put together to get one final image. The NIRCam cannot afford to fail, as without it functioning properly, the telescope will not be able to line up. This will thus raise redundancy. So to avoid this, the telescope comes with two separate camera systems inside, one being the backup on the other in case one of them fails to work. There are small motors behind the 18 hexagonal mirror segments, and they have been delicately pressed onto the plates by shifting and bending them accordingly to create one giant smooth mirror. This means that the movement to be experienced was in nanometers. Due to this very reason, commissioning the telescope took longer than usual. Though it was set up in December 2021, it took the telescope a few months to come out with its first set of images. According to their plan, these images would come out sometime during the summer of 2022, and that's exactly what happened. The mirror that's used in the telescope had to be extremely light in weight, and thus the 18 hexagonal segments were made out of beryllium that weighs only 46 pounds. Though the spacecraft seems quite massive, it weighs only 6.5 metric tons. This is way smaller than the 11.1 metric tons than the Hubble's telescope weighed. The surface of the mirror is plated with gold, thus giving the mirror a golden finishing touch. This golden touch helps in reflecting infrared radiation and is said to do this job much better than what white or silver does. The light that's reflected from the mirror is concentrated onto the 30-inch secondary mirror that's placed opposite the large mirror that's attached to a foldable tripod, which was also deployed into space. The light enters through a gap that's at the center of the mirror where a tertiary mirror is found. This tertiary mirror sends what is collected to the detectors. The launch of this telescope was a big deal for NASA, as well as the various individuals who were a part of this project. The launching of this project went through quite a few phases, including 6 months of gradual deployments, followed by its cooling down, switching on, aligning, and then testing. During the first few weeks, the ensemble will set itself up like origami and will place its parts in the right places accordingly. Webb's lead mission system engineer, Mike Menzel, who worked at the NASA Goddard Space Flight Center in a conference, stated that there must be 144 release mechanisms to make the deployment a success. He further added that there are around 344 single point of failure items, and around 80% of them are related to the deployment. But all the parts of the deployment went according to plan, and some rougher alignments were performed when cooling the system. However, the final tweaking could be done only after the temperature has been stabilized. This was expected to take around 100 to 200 days to do. The James Webb Telescope is one of the most cutting-edge telescopes to have existed so far, and NASA is going to take a maximum benefit from this magnificent creation. And that's all for today, and we hope you enjoyed our video. Drop this video a like, subscribe to our channel, and turn on your post notifications to receive the latest updates from our channel. Bye and see you soon!